A picture for this cannon problem because there's already one on the web page, but I am going to write down the numbers. So the question is saying that there is a 200 kilogram cannon, so mass of the cannon is 200 kilograms, sitting on wheels, and it fires a 4 kilogram cannon ball. So the mass of the ball is 4 kilograms. Now we know the speed of the ball after it's fired, so that's going to be a v prime after the incident happens, is going to be 100 meters per second. And we want to know how fast the cannon goes after the collision or the incident occurs. Not a collision, but after these two objects part ways. Now the other piece of information that's not written in the problem is we know that the velocity of the ball initially is 0, and the velocity of the cannon initially is 0, because before you fire the cannonball, it's not moving, and obviously the cannon's not rolling anywhere either. So from here we can use our conservation of momentum equation, which would be the momentum of the cannon plus the momentum of the ball equals the momentum of the cannon after the ball is fired plus the momentum of the ball after it's fired. So from here, we already established that there's no speed initially, so there's going to be no momentum initially. That's going to go away. So I just have 0 equals the momentum of the cannon prime plus the momentum of the ball prime. That tells me that the momentum of the cannon after the cannon fires has got to be equal to the momentum of the cannonball after the cannon fires. We can now expand. We know our momentum equation is mass times velocity, and that's going to be for each. And if we take a look at the stuff that we've already written down, we know the mass of the cannon. We know we're looking for the mass of the cannon, or the velocity of the cannon. We know the mass of the cannonball, and we know the mass of, the velocity of the cannonball. So we know those things. What we can do is we can really easily rearrange the equation to solve for the velocity. Just divide the mass of the cannon to the other side. And I will get the mass of the cannonball times the velocity of the cannonball prime divided by the mass of the cannon itself. That would be 4 kilograms multiplied by 100 meters per second, all divided by 200 kilograms for the mass of the cannon. And when I plug that into my calculator, I find that the cannon is going 2 meters per second in the other direction, away from the cannonball. So if the cannonball's velocity is positive, if we say this is a positive 100 meters per second, then this would be a negative 2 meters per second because it's in the other direction to conserve momentum.